So very good morning to you all. And today we are going to continue with our unit number 2. The next point, which is associated with the same, that is nothing but a drive RC circuit. It is drive RC circuit. Okay. So consider a series RC circuit. Just a minute, guys. We are going to continue with our next point, that is drive RC circuit. So consider a RC circuit. Let us draw it first. So RC circuit, which has a switch, will be closed at t is equal to 0. RC means resistor, and a capacitor will be connected in series. And there is one voltage source we have connected across the same. Okay. The current will be instantaneous one, which will be with respect to I of t. Okay, so we will assume that the switch is closed. Switch is closed at t is equal to 0. That means before t is equal to 0, the switch was open, right? So for t is greater than 0, so the voltage source is not connected to the capacitor. So there is no initial voltage across the capacitor. I'll just write at t is equal to 0. And after t is greater than 0, okay, so it will be the voltage source. It can be written as Vc of 0 minus, which is equal to Vc of 0 plus, which is equal to 0. Okay, so now we have to start with the derivation. So what is that derivation? The derivation of voltage. Derivation of voltage. So let us start with, as we have defined, at the t is equal to 0, the switch is closed. The circuit will be now, it will be like this one. Okay, which is closed, R is there, and C is connected across it, and this is what the voltage. Okay, R V. Okay, and the current we have defined it as IF. So at t is equal to 0, the switch is closed, and equivalent for t is greater than 0, the circuit will look like this one. Now, what we have to do is, we have to identify or perform the derivation for the voltage. So to start with the derivation of voltage, we need to identify the voltage across the capacitor. So let us call this voltage across the capacitor as Vc of t. Now, by applying what? KVL, we get what we get. The equation will be now V minus I of t into R minus Vc of t is equal to 0. Let us start with V is equal to I of t into R plus Vc of t. Now, here this I of t is what? Is the current passing through the capacitor. And this I of t is given by, how it can be written? I of t is equal to C into dVc of t by dt. Now, let us write the equation numbers. This one we'll call as equation number 1. This one we'll call as equation number 2 and the 3. So let us put equation 3 in 2. We get what we get? V is equal to RC into d by dt of Vc of t plus Vc of t. So let us identify the terms separately. So this can be written as V minus Vc of t is equal to RC dy dt of Vc of t. Okay. Now by separating the variables, we get what we get? We get 1 by RC into dt, which is equal to dVc of t by V minus Vc of t. Now, if we have to take we'll try to separate out those variables. dVc of t by V minus Vc of t is equal to 1 by RC dt. The equation remains the same. Now, by integrating both sides with respect to what? Corresponding variables. Which are those corresponding variables? I have defined it as t. Okay, corresponding variables. Okay, so it will be now, therefore, it will be minus natural log of V minus Vc of t, which is equal to t by RC plus k. What is k? We have already written. It is constant of integration. Okay, so as it is the constant of integration, okay, so what we have to do is we have to calculate k. So to calculate k, put initial conditions as follows. Let us call this equation number as 4. Okay, so from equation 1, at t is equal to 0, we have Vc of 0 minus is equal to Vc of 0 plus, which is equal to 0. Now, by using above equation, okay, equation 4 becomes, how will be your equation 4 will be now? Your equation number 4, it will be minus log of V minus 0, which is equal to 0 plus k. Therefore, k is equal to what? Minus log of V. Now, by putting k in equation 4, we get what we get? We will get it as log of V minus Vc of t, which is equal to t by RC minus log of V. Therefore, log of V minus Vc of t is equal to what? T by RC. Now, multiplying both sides by -1, we get log of V minus Vc of t minus log of V which is equal to minus t by RC. Okay, let us continue the same, minus t by RC. Therefore, your equation will be now log of V minus Vc of t divided by B, which is equal to minus t by RC. Therefore, now taking antilog of both sides, we get V minus Vc of t divided by B is equal to e raised to minus t by RC, isn't it? So let us solve it now. V minus Vc of t is equal to V into e raised to minus t by RC. Therefore, Vc of t is equal to V minus V into e raised to minus t by RC. Okay, so let us call this one as equation number 5. So this equation number 5 is the equation of voltage across capacitor. And here the first term V gives the value of steady state voltage, and the second term, that is V into e raised to t by RC, gives the transient portion of the voltage across the capacitor. So next, now if we have to identify the variation of voltage across the capacitor, let us start with the same. So variation of voltage across capacitor. Okay, so we have already defined this equation number 5. Okay, and with respect to this one, we have to identify the variation of voltage. So what is the equation we have? It is Vc of t is equal to V minus V into e raised to minus t by RC. So what is this 1 upon RC? We have already defined. It is nothing but tau. So the same equation can be written as V minus V into e raised to minus t by tau. Okay. So to plot the variation of voltage across the capacitor, let us consider the values of t. Let us consider value of t, okay, of t as tau, 2 tau, 4 tau, 6 tau, so on. Okay, so for t is equal to 2 tau, Vc of t is equal to what? V minus V into e raised to minus t by tau, which will become now V minus V into e raised to tau by tau means minus 1, which is equal to what? V into 1 minus e raised to minus 1, which is equal to what? 0.632 V. Now, for t is equal to 4 tau. Sorry, actually p is equal to tau. This will be there. And for 2 tau, it will be like Vc of t is equal to V minus V into e raised to minus t by tau, which is nothing but V minus V into e raised to t is equal to what? 2 tau by tau, which is equal to V into 1 minus e raised to minus 2, which is equal to what? 0.8646 V. For t is equal to 4 tau, it will be Vc of t is equal to v minus v into e raised to minus t by tau, which is equal to v into v minus v into e raised to minus 4 tau by tau, which is equal to v into 1 minus e raised to minus 4, which is equal to what? 0.9816 volt. And for t is equal to 6 tau, it is Vc of t is equal to what? V minus 1, sorry, v into 1 minus e raised to minus 6, which is equal to what? It is 0.9975 volt. What does it indicates? Okay, if we go for the similarly for t is equal to infinite, it will be what? Vc of t is equal to v minus v into e raised to minus infinity by tau, which is equal to what? V minus v into e raised to minus infinity is equal to what? Ultimately, this term will be get 0. So it will be a v. What does it indicates? If we draw its graph, it indicates like, okay, the variation of voltage across the capacitor with time, it could be Vc of t is equal to time. Okay, so it will be now like this one, and the maximum voltage will be somewhere like this one. So what it will be? It is tau, 2 tau, 4 tau, 6 tau. Okay, so values will be 0.632, that is 0.8446V. Likewise, okay. So what it indicates? So this voltage across the capacitor increases rapidly till the T is equal to tau, and after this rate, the rate of increases and rate of this T increases, decreases. Okay, and after this T is equal to 6 tau, the voltage becomes, or it reaches to Vc of T. Okay, that is the steady state value. Okay, hope you have understood the variation of voltage across the capacitor. Now, next point that we should continue with, that is derivation of current. So to start with, the current for the capacitor can be expressed as the current for capacitor can be expressed as, how it can be expressed? It is I of t is equal to C into dVc of t by dt. Okay, therefore, let us call this one as equation number 1. Okay, so we have already gone through one more equation. What is our initial equation? That is the equation that we have for the voltage. What is the voltage equation? We know that Vc of t is equal to what? We have already written. Okay, it is v minus v into e raised to minus t by RC, isn't it? Let us call this one as equation number 2. Now, by putting what equation 2 in 1, we get what we get? I of t is equal to C into d by dt of v minus v into e raised to minus t by RC, which is equal to C 0 minus v into minus 1 by RC into e raised to minus t by RC. Therefore, IC of t is equal to V by R into e raised to minus t by RC. Okay, let us call this equation number 3. So this equation, okay, we know that what we know, t is what? RC time constant. So this equation of current through the capacitor, okay, we know that tau is equal to what? RC. Therefore, IC of t, it will be now V by R into e raised to minus t by tau. This is what the derivation of current. Now, if we have to identify the variation of a current, what it will do. Okay, so to start with, the variation of current. So variation of current for the RC circuit. So to plot the variation of current with respect to time, we have to consider the values of t. So what we have to consider, the initial value for t is equal to 0, IC of t will be V by R into e raised to 0. It is what? V by R. Next, for t is equal to tau, it is IC of t is equal to V by R into e raised to minus what? Tau by tau. It is V by R into e raised to minus 1, which is nothing but what? 0.3678 V by R. Now next, for t is equal to 2 tau, IC of t is equal to V by R into e raised to minus 2 tau by tau, which is nothing but what? V by R into e raised to minus 2. It is 0.1353 V by R. Now, for t is equal to 4 tau, IC of t is equal to V by R into e raised to minus 4 tau by tau, which is equal to V by R into e raised to minus 4 is equal to what? 0.01831 V by R. Last, for t is equal to 6 tau, IC of t is equal to V by R into e raised to minus 6 tau by tau, which is nothing but V by R into e raised to minus 6. Okay, so it will be 0.0024 V by R. What it indicates? The values are decreasing. So how will be its response? It will be at initial condition. This is what the maximum value will call. So it has started decreasing, but not to 0. Okay, it is V by R, and somewhere over here it is 3678.3678. Sorry, here 0.3678 V by R, and this value is nothing but what? It is the T, isn't it? It is T. So what it indicates? So the variation of current, okay, so the variation of current decays exponentially, okay, which is nothing but the current rapidly decreases to the value 0.3678 V by R at t is equal to tau, and after that the rate of decay decreases and the current reaches steady state value at t is equal to tau. Understood? Okay. One more condition is there, that is for if t is infinite, then IC of t, it will be V by R into e raised to minus infinity, which is nothing but 0. Okay, so it means when the current will be defined for the derivation of current, so for the variation for of RC circuit, it will be, the current will be decreasing slowly. Okay, slowly, initially it will decrease rapidly, and then it will be a slow one.